Welcome to lecture series EPG Padasala for Computer Science. In this lecture, I will be summarizing project lifecycle components and infrastructure components till corrective and preventive actions. These topics were discussed in detail in the previous lectures. Learning objectives: outline the various software testing strategies and their implementation, summarize the importance of computer aided software engineering tools in software quality assurance, summarize the software quality infrastructure components, procedures, work instructions, staff training and certification, outline the importance of corrective and preventive actions in maintaining software quality. Major contents of this presentation has been prepared from the textbook Software Quality Assurance from Theory to Implementation, authored by Daniel Gellin, Pearson Education Limited, 2004. Let me first outline the different software testing strategies. Testing is the process of executing a program with intention of finding errors. The formal definition of testing is the process of analyzing a software item to detect the differences between existing and required conditions, that is bugs, and to evaluate the features of the software item. Objectives of software testing: direct objectives to identify and reveal as many errors as possible in the tested software, to bring the tested software after correction of the identified errors and retesting to an acceptable level of quality, to perform the required tests efficiently and effectively within budgetary and scheduling limitations. Indirect objective: to compile a record of software errors for use in error prevention by corrective and preventive actions. There are basically two software testing strategies: Big Bang testing, incremental testing. Big Bang testing is not a practical approach because Big Bang testing tests the software as a whole once the completed package is available, or to state it in other words, all the modules are integrated and finally tested. Bug fixing is a complicated task. Incremental testing: this is the most practical approach towards testing a software product. Each module is individually tested and then integrated. Software modules are tested as they are completed. Unit tests, followed by groups of modules composed of tested modules which are integrated with newly completed modules. In incremental testing, a module is integrated with another module in an incremental fashion, tested, errors if any are detected and corrected. Once the entire package is completed, it is tested as a whole, which is termed as system test. The most practical approach towards testing is the incremental approach. Let me now discuss the software test classifications. First, classification according to testing concept: black box testing and white box testing. In black box testing, bugs are identified only according to software malfunctioning as they are revealed in the erroneous outputs. In cases that the outputs are found to be correct, black box testing disregards the internal path of calculations and processing performed. To be brief, black box testing is concerned with input and output. It is not concerned with the program or the code. White box testing examines internal calculation paths in order to identify bugs. It investigates the correctness of the code structure. Pros and cons of black box testing. The main advantages of black box testing are it allows the tester to carry out almost all test classes. Black box testing requires considerably fewer resources. The main disadvantages of black box testing are it allows for identification of coincidental errors as correct. It lacks control of line coverage. It lacks possibilities to test the quality of coding work. Pros and cons of white box testing. The main advantages of white box testing are it permits direct checking of processing paths and algorithms. It provides line coverage follow-up that delivers list of lines of code that have not yet been executed. It is capable of testing the quality of coding work. The main disadvantages of white box testing are it requires vast resources, much above those required for black box testing. It cannot test the performance of the software in terms of availability, reliability, stress. Software test classifications, classification according to requirements. McCall's model has been extended here to the classification of the tests carried out to ensure full coverage of the respective requirements. Factor category, operation, quality requirement factor, correctness, reliability, efficiency, integrity, usability. Test classification according to requirements, output correctness tests, documentation tests, availability tests, data processing and calculations correctness tests, software qualification tests, reliability tests, stress tests, software system security tests, training usability tests, operational usability tests. Factor category, revision, quality requirement factor, maintainability, flexibility, testability. Test classification according to requirements, maintainability tests, flexibility tests, testability tests. Factor category, transition, quality requirement factor, portability, reusability, interoperability. Test classification according to requirements, portability tests, reusability tests, software interoperability tests, equipment interoperability tests. Testing implementation, planning, design and performance of testing are carried out throughout the software development process. These activities are divided in phases, beginning in the design stage and ending with the software installed at the customer's site. Testing process is diagrammatically illustrated, determining the test methodology, next planning the tests, designing the tests and performing the tests. Automation testing. Automated testing tools are capable of executing tests, reporting outcomes and comparing results with earlier test runs. Tests carried out with these tools can be run repeatedly at any time of day. The method or process being used to implement automation is called a test automation framework. The main types of automated testing are code auditors, coverage monitors, functional tests, load tests and test management. Let us discuss one after the other. Code auditors. The code auditor checks the compliance of code to specified standards and procedures of coding. Coverage monitors. Coverage monitors produce reports about the line coverage achieved by implementing a given test case file. Functional tests. Automated functional tests replace manual black box correctness tests. Load tests. The load tests are based on simulated scenarios of maximal load situations the software system will confront. An automated testing system enables measurement of the expected performance of the software system under various load levels. Test management. The main objective is to provide comprehensive follow-up and reporting of the testing and correction of detected errors. Alpha and beta testing. Alpha site testing is a method by which customers try out the new software package at the developer's site. Beta site testing is a method by which a selected group of users or customers receive an advanced version of the software to be installed in their sites and report the errors they find in the process of their experiments with the program and the program's regular use. Software maintenance foundations. Two factors are considered to be the foundations of high quality maintenance. Software packages quality could be guaranteed by implementing software quality assurance activities throughout the development process and should begin in the earliest phases of software development. The main constitutes of maintenance policy are version policy and change policy. The version policy saves the resources needed to cope up with maintenance of several versions and allows the team to focus on effective, reliable, corrective and adaptive maintenance in addition to the development of a comprehensive improved version of the original package. Change policy is a balanced policy that approves only a small proportion of worthwhile changes as a result of its focus on the most important beneficial changes is preferable to a permissive policy that approves every change required. Software maintenance components. There are three components of software maintenance, each doing the following: corrective maintenance, adaptive maintenance, functionality improvement maintenance. Corrective maintenance of software corrections and user support services. Adaptive maintenance adjusts the software package to the requirements of new customers and changing environmental conditions. Functionality improvements maintenance combines maintenance activities with improvement of software performance and reliability. Infrastructure tools that support maintenance quality assurance. The major software quality assurance maintenance infrastructure tools are software maintenance procedures and work instructions, training and certification of maintenance teams, quality supporting devices, preventive and corrective actions, configuration management, software maintenance documentation and quality records. External participants and software quality assurance. Contractors versus external participants. Software development contractors or organizations or group of organizations that are controlled by a customer. External participants are organizations that participate in the development process, performing small to large parts of the work, but are not legally designated sites in the project's contract. External participants and software quality assurance. The external participants can be categorized into three main groups: subcontractors, suppliers of commercial, off-the-shelf software and reused software modules, the customer themselves as an active participant in performing parts of the project. Benefits of external participants. The main benefits to the contractor of using external organizations are overcoming shortages of professional staff by transferring parts of the project to be carried out to firms employing staff having those skills, potentially shorter project schedules achieved by purchasing commercial off-the-shelf software and reused software rather than developing the software. Expertise occurred in areas that need specialization through the participation of owners, the subcontractor or the customer's development department of that expertise. Saved budget achieved when subcontractors offer prices below those incurred by performing the project internally and by the use of commercial off-the-shelf software and reused software. Software quality assurance tools for external participants. The requirements document review. It assures a correct and complete list of the requirements related to the software functionality. Choice of external participants reduces all types of risks, especially those related to low quality. The project coordination and joint control committee discovers anticipated as well as unanticipated delays and quality problems. Participation in software testing, participation in design reviews contribute to the reduction of low quality products. Furthermore, such participation enables the contractor to be alerted about possible delays in the work schedule. Specialized procedures. These are part of the contractor's software quality assurance infrastructure and are meant to handle all kinds of risky situations. Qualification and certification of the suppliers, team leaders and other staff. Assure the professional capacities of the project teams. Progress reports of external participants' development activities. These are prepared mainly in order to reduce the risk of delays. Review of deliverables and acceptance tests. It is aimed at assuring the quality of the work performed by the external participant and consequently reduces the risk of future maintenance difficulties. Case tools, computer-aided software engineering tools or computerized software development tools that support the developer when performing one or more phases of the software lifecycle and support software maintenance. Contributions of case tools to product quality, identification of deviations from design requirements, identification of design inconsistencies, automated generation of code based on the repository design records with no expected errors, full compliance with design and coding documentation instructions achieved by the automated coding, high quality corrections and changes made during development due to the repository tool support, automated generation of a repository of legacy systems by case reverse engineering tools which enable efficient development of new generations of the software system with maximal assurance of software quality. Contributions of case tools to maintenance quality. The full and updated documentation provided by case repositories assures the consistency of repairs, changes and additions within the existing system. The cross-referencing repository tool facilitates planning and prevents a significant proportion of design errors. The automated coding carried out by case tools eliminates coding errors. Software quality infrastructure components. Components of infrastructure are employed to prevent software errors and promote the quality level of the entire organization. The typical infrastructure components are procedures and work instruction, quality support devices like templates and checklists, staff, software quality assurance training and certification activities, preventive and corrective actions, software configuration management, documentation and quality records control. Procedures and work instructions. Procedures or activities performed in order to achieve given tasks. Work instruction tools are used to define local variations in the application of the procedures by specific teams or departments. Work instructions, however detailed and targeted, cannot contradict the organization's procedures. Procedures supply details needed to carry out a task. These details can be viewed as responding to 5 issues known as the 5 W's. What activities have to be performed? How should each activity be performed? When should the activity be performed? Where should the activity be performed? Who should perform the activity? Work instructions. Work instructions deal with the application of procedures adapted to the requirements of a specific project team, customer or other relevant party. Software quality assurance work instruction subject examples: departmental work instructions, audit process for new software development subcontractors, priorities for handling corrective maintenance tasks, annual evaluation of software development subcontractors, on-the-job instructions and follow-up for new team members, design documentation templates and their application, C++ or other language programming instructions, project management work instructions, coordination and cooperation with the customer, weekly progress reporting by team leaders, special design report templates and their application in the project, follow-up of beta site reporting, monthly progress reporting to the customer, coordination of installation and customers team instructions. Supporting quality devices. Templates refer to a format created by units to be applied when compiling a report or some other type of document. Contribution of templates to software quality assurance. Documents submitted for review tend to be more complete. As a result, review teams can direct their efforts to further improvement of the final project. Document reviews are facilitated as their structure is standard and well known among reviewers. Reviewers can focus on issues of document content. Supporting quality devices. The checklist used by software developers refers to the list of items specially constructed for each type of document. Contributions of checklist to software quality assurance. Checklists support document completeness and improve document quality. Conduct of review sessions becomes less problematic when topics and their order of priority are defined. An efficient session is expected to carry out a thorough analysis of comments by reviewers. Staff training and certification objectives. To develop the knowledge and skills needed by new employees and to update the knowledge and skills of existing employees. to impart knowledge of style and structure procedures and work instructions to assure conformity of software products to the organization's standards, to impart knowledge of software quality assurance procedures, to assure that the qualifications of candidates for key professional positions conform to the position's requirements. Activities related to staff training and certification determine the knowledge requirements for each position. Knowledge obtained while acquiring a general professional education with the addition of the internally generated knowledge determine training and professional updating needs. These needs are ascertained through comparisons of the staff's knowledge with the state of art. Plan training and updating programs. These programs will respond to the following issues: the use of in-house training teams and facilities or outsourcing, the timing of the training and updating activities whenever possible, the use of e-learning programs. Certification components. Certification requirements may include some or even all of the following components depending upon their relevance to the task or position: professional education, internal training courses, professional experience, evaluation of the candidate's achievements and ability, evaluation by the candidate's direct superior, demonstration of knowledge and skills by means of a test or a project. Corrective and preventive actions. Successful operations of a corrective and preventive action includes the following activities: information collection, analysis of information, development of solutions and improved methods, implementation of improved methods, follow-up. Summary: various testing strategies and their implementation techniques have been discussed. The impact of infrastructure components such as procedures, work instructions, staff training and certification on software quality has been discussed. Corrective and preventive action is a vital infrastructure component in ensuring software quality. I acknowledge the authors of the books which I have referred and the web resources I have used for this presentation. Thank you.